Now, what if we want to check out more than just one k value? In the previous video, we looked at k equal to 4. What if you want to check out, say, k equal to 1, k equal to 2, k equal to 3, and so on? And this can be very easily done with tuning parameter in caret. But here, let's look at the code, which is kind of a little involved, and this code is in your textbook. And we need to use a for loop and then run the KNN the KNN procedure from FNN for each k, and then capture the accuracy value so we can then see which one has the largest accuracy. So we have to first create an empty data set where we are going to populate it when we run the for loop. So we set this up as a kind of a template, right? An empty data set, data frame. So it's going to be data frame procedure, right? So it has two parentheses, and then we specify the parameters for how to populate this data, this accuracy.df as a data frame. So we can now specify column name and what that column should have, or column name and what the column should have. So we'll call the first column to be k, and then we'll say sequence 14. So we're going to try 14 different values for k, right? K equal to 1 to 14. If you wanted k to try 7 of them, then you'll just make it as 1 to 7. Okay? So that's the first column, and then the second column, let's call that accuracy equal to. Okay, now we don't know the accuracy yet because we're going to run the nearest neighbor model for k equal to 1 through 14 and then capture the accuracy and populate it. So right now we're going to say, okay, I'm going to populate it at this point in time with zeros, and the REP is repeat. So I say this function is repeat 0 14 times. Okay. So now if you go to accuracy.df, you see that k is 1 through 14. K is the name of the column. Accuracy is the name of the second column. They are all zeros. Okay. So now we run the KNN procedure. Okay. And we're going to repeat it. So we'll say for I in, right, 1 through 14. Okay. So I will repeat, I will go through the sequence 1 through 14. Okay, and then do what? Okay, and then we have this squiggly bracket. I'm going to press enter, so it'll be put to the other side. So we'll have whatever commands, whatever code that we enter here between the left and the right squiggly bracket, that's what is going to be executed in the for loop. So what we want to do here is I'm going to copy paste that code. So we want to run that code, right? So let's tab over. Okay, and then we specify k as k equal to I. So first time k will be equal to 1, second time k will be equal to 2, and so on. Okay, and then after that we have to run the confusion matrix. Okay, let's confusion matrix. Okay, so before we do this, let's do a confusion matrix right here. We already have run knn dot fnn, right? So let's just run the knn code with valid. Okay, so here the test data is going to be valid dot norm dot df, and let's run this for k equal to 4. Okay, and then we will run a confusion matrix and then see how that turns out. Okay, so okay, so we need to specify that only the first two columns, so it has to be like that. Uh, all rows of the valid, but columns 1 to 2. Okay. Now when we run, so we have the knn results now. Okay, so it will have the predicted. Okay, if you look at knn dot fnn, okay, so here the first item is the predicted values for the valid.df set, and then this is the index, these are the distances like what we saw previously. So now we have the predictions. Okay, so confusion matrix, okay, we can run the confusion matrix now, confusion matrix, and we have to specify the predicted class, and then the actual class. Okay, so predicted class is in knn dot fnn. Okay, and the actual class is in valid dot df. Okay, valid norm dot df. Well, it's the same thing because the ownership column is non-numeric. So anyway, ownership. Okay, but this will not run because remember ownership is a character variable, but confusion matrix requires this to be a factor. So if you run, you'll get an error. Okay, so we need to say as factor okay, predicted class and then the actual class. Okay, so now you see the confusion matrix results are shown here, and here is the accuracy. Okay, so if you want only the accuracy, then you have to specify dollar overall. So it is in overall. Well, let's look at, so let's put this in a temporary variable called x. Then we can look at x and see what we have. So here is overall and here is accuracy. So within overall, the first item on the accuracy is what the accuracy value is. So you have to specify here dollar overall, and the accuracy is the first item. Okay, so that's the code that we have to run here, right? And we need to change this to valid.norm. Okay, and then we take, okay, so now we're going to run, so make sure that for the I in 1 to 14 is in parentheses, otherwise for will not work. So make sure that that is so. Now once we've already tested where to get the overall accuracy from, okay, now remember we need to set that into this data frame. So it's going to go into accuracy.df. So and this one has two columns, remember. First column is K, 1 through 14. The second column is accuracy. So whatever I is, it's going to have to go to that row. And then the second column is where the accuracy needs to be saved. Okay, so now we can run this code. Okay, so train.norm, valid.norm. Okay, all rows of train, columns 1 and 2 are the predictors, and same here. And the class for the train set is that. Now K, the number of nearest neighbors, is going to be I, and I will cycle through from 1 through 14. Okay, now we print the accuracy.df, and here is what we see. Well, run accuracy.df has this. Okay, and we can of course eyeball this and see where you get the maximum value, right? And suppose you want to do that automatically. So one way of doing that is to use the which procedure, which method. Okay. So say which. Okay, so now what we're trying to do is we're going to take each accuracy value and compare it to the maximum value, right? So if you say accuracy.df, okay, accuracy, right? So that's what we want to check, and we want to compare. Therefore, you need to use two equal signs. And is it equal to the maximum of what? Of accuracy.df accuracy. So that this will find the maximum, and which will do is it will go from top to bottom, compare each one of them, and then it will tell you which rows have that maximum value. So if you run that, then you get 14 here, right? So that's going to give us the row number which has the maximum possible value for accuracy. So if you want that accuracy to be printed, so this is your row number, so we can say accuracy.df. Okay, that's a data frame. So that's going to give us the row number, right? Okay, and then what do you want to print? You want to print the second column. And if you run that, no, okay, I need to finish that with a square bracket. You run that, and that tells you 0.875. Okay, you want K also with this, then you'll have to print that part alone.